Hi, this is Margo. This is Tuesday, June 26, 2018, and hopefully I will be able to finish presenting the information on ozone in this part today. If my computer doesn't crash, if everything stays up and running, this will be part 3 of looking at ozone that I started. And just a little review, and if you haven't seen parts 1 and 2, I encourage you to go look at those because we're building on what we see in each one. Now, I've already shown everyone how to look at ozone levels on CAMS. This is the Copernicus Atmosphere Monitoring Service, and I will leave the links below. And this is from the Arctic view, and this is from the plots view on the globe, and it's tracked in total ozone or column is tracked in DU or Dobson units, and average ozone they figure is 300 DU, and 300 Dobson units equals to about 3 millimeters. So the ozone layer is very thin and it's very precarious. And I also, just a second, and here's a converter chart. If you want to convert millimeters to inches, for people in the West who want to understand how thin it really is, 3 millimeters is equal to 0.11 inch. And where it says like 250 Dobson units, that's 2.5 millimeters. 2 millimeters is 0.07 inches. So you can do the math from there. And I also showed people yesterday about looking at bad ozone layers or levels, and when you click on surface here, you can see this is the ozone that's being created at the surface, and this is called the bad ozone. And I did a long thing on that yesterday, so that's in part 2. And the EPA says that when it gets up to 70 parts per billion and higher, if you're breathing that for more than 8 hours, then it can be detrimental to the health, especially for people who have respiratory issues and asthma and things like that. So there's that, and we showed how that worked yesterday. And I wanted to share another website. This one is current ozone values. Now this is for bad ozone, what we just looked at. And if you live in the United States, you can just type in your zip code up here and it'll go to your zip code and show you the ozone values where you live. And here are just some towns, and here's how it's measured. They measure good as 0 to 50, moderate is, or this is AQI, Air Quality Index, moderate is 51 to 100. So even if you're sensitive, that could be bothering you if it's in the moderate range. Unhealthy for sensitive groups is 101 to 150, that's orange. Unhealthy for everyone is 151 to 200, that's red. Very unhealthy is purple, that's 201 to 300, and that's for everyone again. And hazardous is an emergency condition, that's 301 to 500. And yesterday we talked about where bad ozone comes from, and it's formed as a result of sunlight and heat interacting with pollution that specifically comes from gas emissions, cars, industrial plants, things like that. And so you're going to see more bad ozone levels being created in highly populated areas that have a lot of industry going on. So let's look at, like, for instance, here's Coachella Valley, California. They're at 87. So that's moderate. Colfax, California is 32, so they're in the green, so they're okay. Columbia, South Carolina, they're 24. They're okay. Death Valley, 93. So it's hot there, and there's pollution that's gathering from the west coast and coming across, and it probably sits down in that valley. But 93 is still considered moderate, in the moderate zone, and safe for most groups of people. Let's see if we can find any red. Any red ones. Of course, it's pretty early in the day, so I don't know if you'll see any red yet. Feeling, California is 100, so they're on the borderline of being moderate. So I think if you look at this website, then look at it during the day, you'll see the numbers change as it heats up during the day, and you'll find areas that are not safe. So there's that. Then I'm just going to start going through all these websites that I have up here, because I've given you the foundation. Now we're building on it. And we talked about how the ozone layer is thinning around the middle part, around the equator, and how scientists don't know what's causing that. And I've pulled up 2 articles that talk about that. This is from technologyreview.com. This is from February 6th, 2018, this year. Says the ozone layer is thinning in places around the equator. The planet's natural protection from UV radiation may be in danger over some of the world's most populous areas. Oh, and if you've got UV radiation coming through, then that causes a lot of problems with skin cancer and eye issues. It breaks down the DNA. It breaks down the phytoplankton in the ocean. I mean, it's a whole thing. So where the ozone layer is thin, then the bad radiation from the sun comes in and causes a lot of problems. Here's the backstory. Huge ozone loss hit Earth in the 1980s, especially above Antarctica. The Montreal Protocol banned the chemicals that were responsible for the depletion, and ozone levels in the upper atmosphere grew again. Now that was the banning of the chlorofluorocarbons and bromine, I think. Well, that was like the cans, spraying stuff like hairspray, things like that. What's new? In a paper published in Atmospheric Chemistry and Physics, researchers explain that the ozone in the lower stratosphere is now thinning at lower latitudes. Near the equator, where billions of people live and sunlight is at its most intense, the resulting loss of UV protection could be disaster. What's causing it? That's still unclear. it may be that changes in atmospheric circulation due to global warming are shifting ozone toward the poles, or some industrial chemicals once thought to safely break down in the lower atmosphere may in fact make their way high enough to account for the damage. Now, we've also been seeing a lot of sulfur dioxide that's been coming across through the equator from Hawaii and different areas with the volcanoes. So, it could be sulfur dioxide that's going up and breaking down the ozone. We talked about that too. Here's my next one, my next article. This is from Science, and this was from February 6th, 2018. And here they're showing where it's thinning. That green is their version of the thinning of the ozone layer. It says an unheralded group of chemicals may complicate the current view of ozone depleting substances in the mid-latitudes, NASA Goddard says. May be tied to short-lived chemicals. Hi, I'm back. They crashed my computer and had to take a little break, so I'm going to pick up where I left off. This is an article from sciencemag.org, and it was published on February 6, 2018, and it says disturbing losses of protective ozone near Earth's equator may be tied to short-lived chemicals. And here's their version of the thinning of the ozone around the equator. On cams we saw that as the blue, the light blue. It says 30 years after nations banded together to phase out chemicals that destroy atmospheric ozone, the gaping hole in Earth's ultraviolet radiation shield above Antarctica is shrinking. But new findings suggest that at mid-latitudes where most people live, the ozone layer in the lower stratosphere is growing more tenuous for reasons that scientists are struggling to fathom. I don't want people to panic or get overly worried, says William Ball, an atmospheric physicist at the Physikalisch Meteorologisch Observatorium Davos World Radiation Center in Switzerland. But there's something happening in the lower stratosphere that's important to understand. Several recent studies, including one published last month in Geophysical Research Letters, point to a robust recovery of stratospheric ozone concentrations over Antarctica, the long-awaited payoff after the Montreal Protocol in 1987 mandated a global phase-out of chlorofluorocarbons and other ozone-eating compounds. But recent evidence indicates that the global campaign to mend the ozone layer is far from over. In an analysis published today in Atmospheric Chemistry and Physics, Ball and colleagues combined satellite data to examine ozone at mid-latitudes from Earth's surface up through the troposphere and the stratosphere. They found that from 1998 to 2016, ozone in the lower stratosphere ebbed by 2.2 Dobson units, a measure of ozone thickness, even as concentrations in the upward stratosphere rose by about 0.8 Dobson units. We saw it at almost every latitude and every altitude below about 25 kilometers, Ball says. That made us very concerned that perhaps this was something very real that no one looked at before. The ozone layer's total thickness, not just concentrations in the upper atmosphere, is vital for absorbing UV light. What matters most for UV at Earth's surface is the total column amount of ozone overhead, says co-author Sean Davis a research scientist with NOAA's Earth System Research Laboratory in Boulder, Colorado. Although previous studies had suggested a decline in lower stratospheric ozone, no one had combined satellite data to look at what was happening across such a wide swath of the globe and so far down in the ozone layer. Ball and his colleagues suspect that the culprit is very short-lived substances, or VLSSs, ozone-eating chemicals such as dichloromethane that break down within 6 months after escaping into the atmosphere. Researchers had long assumed that VLSS's short lifetime would keep them from reaching the stratosphere, but a 2015 Nature Geoscience study suggested that the substance may account for as much as 25% of the lower stratosphere's ozone losses. Whereas many VLSSs are of natural origin, marine organisms produce dibromomethane. For example, use of human-made dichloromethane, an ingredient in solvents and paint removers, has doubled in recent years. We should study VLSSs more completely, says Richard Rood, an atmospheric scientist at the University of Michigan in Ann Arbor, but because the compounds are released in small quantities, he says they're going to be difficult to measure. Climate change may also be a factor. For example, by sweeping ozone out of the tropics, the study suggests. It's vital to determine what's eating away at ozone in the mid-latitudes, where the majority of the world's population resides. The potential for harm in lower latitudes may actually be worse than at the poles, says Joanna Hay, co-director of the Grantham Institute at Imperial College London. The decreases in ozone are less than we saw at the poles before the Montreal Protocol was enacted, but UV radiation is more intense in these regions. Ball and others emphasize that the Montreal Protocol has still been a success. I don't think it in any way says there's something fundamentally wrong with how we've been dealing with the ozone problem, says Rood, referring to the study. What it says to me is that we're now looking at effects that are more subtle than that original problem we were taking on when the Montreal Protocol was adopted. And that's the end of the article. So the area they're talking about affects where people like to go vacation as well. And so if they're out on the beach and wanting to get sun, well, they're getting a lot of UV radiation as well. And so you've got melanoma increasing, all kinds of skin cancer, all kinds of eye diseases, cataracts, corneal conditions. I'm thinking dry eye syndrome might be part of this. It's a whole combo plate. So we're going to go to the next article now. Now, as a result of doing the long video and research on nuclear radiation at Novaya Zemlya and the testing during the Cold War up there and all of that, I did that long video revealing what I'd found on all of that. I thought, well, could nuclear radiation be depleting the ozone layer? And I found some interesting information, some interesting articles that say yes, nuclear radiation and nuclear power plants can be eating away and causing the ozone layer to be decreasing. So here's my first article. It's from the NTI.org. And it says limited nuclear war could deplete ozone layer, increasing radiation. And this was from February 24th. I think this is an old article. I'm not sure of the year. And it's showing a 1971 French nuclear test at Mururoa Atoll. The ozone layer could sustain lasting harm from a nuclear exchange involving as few as 100 weapons, allowing increased levels of ultraviolet radiation to reach the Earth's surface, according to new research. And this is from Washington. A nuclear conflict involving as few as 100 weapons could produce long-term damage to the ozone layer, enabling higher than extreme levels of ultraviolet radiation to reach the Earth's surface, new research indicates. See GSN, March 16, 2010. Increased levels of UV radiation from the sun could persist for years, possibly with a drastic impact on humans and the environment, even thousands of miles from the area of the nuclear conflict. A regional nuclear exchange of 100 15-kiloton weapons would produce unprecedented low ozone columns over populated areas in conjunction with the coldest surface temperatures experienced in the last 1,000 years, and would likely result in a global nuclear famine, according to a presentation delivered on Friday at a major science conference in Washington. Today there are 5 recognized nuclear powers: China, France, Russia, the United Kingdom, and the United States. India, Israel, and Pakistan are all known or widely assumed to hold nuclear weapons, while North Korea has a deterrent of undetermined capability, and there are concerns about the atomic intent of nations such as Iran. You can tell this is an old article, but okay, I'm going to go ahead and continue. I'll leave links below. This goes on, but what they're saying is that nuclear weapons waste the ozone layer. They waste it for thousands of years. And when they're saying nuclear exchange of 115 kiloton weapons, these would be weapons that were exploded above the ground in the air. And if you go back to the Novaya Zemlya video that I showed, that I did, I mean, there were 224 weapons tested by the Soviet Union over Novaya Zemlya and underground during the Cold War, and they were, very few of them were low kiloton like that. They were megatons. And even the Tsar Bomba, which yielded 58 megatons, that was dropped over Novaya Zemlya. And so all of that went up into the atmosphere and blew open the ozone. And then, of course, the United States did all the testing in the Marshall Islands. These were above ground testings, most of them. Then the United States, then there's been a lot of above ground testing in Nevada and different places. Of course, the first nuclear bomb was dropped at Trinity Test Site in New Mexico. And these are huge. These were huge weapons of mass destruction that have been dropped all over the place. And then, you know, so it's all over, in every country that has nuclear weapons tested them, and a lot of them tested above ground, a lot of them do below ground, which I believe has its own problems. But right now they're talking about above ground. So you can read this article. Here's my next article that I have. This is from Nuclear News. I'm not sure when this was posted. I'll leave the link below. But, you know, the powers that be, the heads of government, heads of states, already know about all of this. They already know. The scientists have been yelling about this from the beginning, and the researchers have been yelling about this from the beginning, and yet they went ahead with all of the nuclear bombs, all of the nuclear testing, and nuclear power in spite of all of the warnings from the experts. And so I see, the way I see it is, you know, it's just, we're done. We're done. We're done. And this makes me sick to see this. It makes me sick to see it and understand on such a deep level of how we're done. And I just can't be happy. I don't have any joy. I don't have a life. I mean, I come under attack 24/7, and now that I'm trying to do these videos, I come under constant attack technologically in different ways, and my health is not good, and we're so near the end, and I just hope that some people are getting some good information from these videos and are going to a spiritual solution, because that is the only solution, is a spiritual solution, because this physical reality is over and the only way out is spiritually. So this is from Nuclear News. Nuclear radiation depletes the ozone layer and will eventually destroy planet's oxygen. Hazards of low-level radioactivity. Nuclear reader. Ozone breakdown. The protective layer of ozone around the Earth filters out solar and cosmic rays and prevents them from reaching our planet. Ozone surrounds the Earth in a layer between 6 and 30 miles above sea level. It is formed when light rays strike molecules of oxygen, which is O2, and causes them to break into two separate oxygen atoms, or an O and O. An atom of oxygen then combines with a molecule of oxygen and forms ozone, which is O3. It breaks down again and then recombines again, and so on, unless it is interfered with. Radiation interrupts the process of ozone formation. And you can read that. Ozone, a molecule with 3 oxygen atoms. The troposphere is the lowest layer of the Earth's atmosphere, extending about 7 kilometers above the poles and 20 kilometers above the tropics. Stratosphere, the second layer of the Earth's atmosphere containing the ozone layer. It's about 10 to 50 kilometers above the Earth's surface. Dobson, the unit in which ozone concentration is measured. And then it just takes quotes from different articles that have been published down through the years with all of these experts warning about nuclear testing and nuclear radiation and nuclear power and all this stuff. Warning. In 1957, Walter Russell published his book Atomic Suicide, whose principal message was that the development of the nuclear weaponry and nuclear industry, if it continued, would eventually destroy the planet's oxygen. And this is what's happening now. The oxygen is dropping, the oxygen level is dropping, and we're suffocating. We're in this toxic soup and we can't breathe, we can't function, and the whole planet is suffocating. The element of surprise, which could delay the discovery of the great danger and thus allow more plutonium piles to come into existence, is the fact that scientists are looking near the ground for fallout dangers. The greatest radioactive dangers are accumulating from 8 to 12 miles up in the stratosphere. The upper atmosphere is already charged with death-dealing radioactivity for which it has not yet sent us the bill. It is slowly coming, and we will have to pay for it in another century, even if atomic energy plants ceased today. And that was from Walter Russell and Lau, Atomic Suicide, University of Science and Philosophy, Virginia, 1957. He knew, and he told it way back then. Here we go. 1982 and 84. Two German reports conclude that radioactive krypton, which is released in the daily operation of nuclear plants and through the reprocessing of used reactor fuel elements, is affecting the distribution of the electric fields in the atmosphere. What's interesting, krypton is what was Superman's enemy. Krypton, it could be our enemy too. 1987, the ozone hole is twice as large as the U.S. It is discovered that ozone is not only diminishing over the South Pole, but globally. And see, when they talk about building back the ozone hole, they don't say one word about nuclear. 1987 to 88, consensus has it that vaporous man-made chemicals are the sole cause of ozone breakdown, especially compounds of chlorine, CFCs, and bromine from halon fire extinguishers, and there was an attempt to implicate hairspray in refrigerators. A leading authority on the ozone problem, NASA's Dr. Robert Watson, admitted many scientists were baffled by findings of ozone depletion even in areas where CFC's action was negligible. He called the extent of the hole's growth absolutely unexpected. April 6, 1989. Scientists reported yesterday that for the first time they have detected an increase in biologically relevant levels of ultraviolet radiation reaching the ground as a result of the ozone hole over the Antarctic. This is the first indication that the depletion of ozone is beginning to cause the potentially harmful effect that has long been predicted. Late 1990. University of California researchers published their findings that phytoplankton are reproducing less profusely than before. Observing the phytoplankton in the Bellingshausen Sea in the Antarctic, they found that increased UV appears to be suppressing the phytoplankton's productivity by 6 to 12%. And that's the root of life on the planet. That's what all the marine animals feed on. It starts with the phytoplankton. When that goes, we're gone. 1992, both NASA and the World Meteorological Society reported 10 to 25% ozone depletion measured over the northern United States, Canada, Europe, and the Antarctic, and the ozone hole is now 3 times the size of the United States. 1994, an article in German journal Strahlentelix, March 3, 1994, argues that the nuclear industry is responsible for the hole in the ozone. The authors, Geibel and Sternglass, explained that radioactive gases like krypton-85 from nuclear plants and from the recycling of spent fuel go up to the stratosphere where they create water droplets from the moisture, which in turn form ice crystals, which enhance the destruction of the ozone by the fluorohydrocarbons. Krypton 85 has a half-life of 10.7 years and a whole life of 217 years. So that's not going away. March 1996. The World Meteorological Agency reports the extremely worrying development of an unprecedented 45% ozone thinning over Greenland, Scandinavia, and western Siberia. Summer 1997. Research from the Antarctic Marine Living Resources Program find krill abundance in the Antarctic Peninsula region is down 60 to 90% since the early 1980s. So I'm going to leave a link to that below. Let's see if there's more. Oh yeah, and then the comments. The comments are really good too. So, you know, they're not factoring in nuclear. None of the climate scientists factor in nuclear in anything. Here's another article, atomicarchive.com, ozone depletion. When a nuclear weapon explodes in the air, the surrounding air is subjected to great heat, followed by relatively rapid cooling. These conditions are ideal for the production of tremendous amounts of nitric oxides. These oxides are carried into the upper atmosphere, where they reduce the concentration of protective ozone. Ozone is necessary to block harmful ultraviolet radiation from reaching the Earth's surface. The nitric oxides produced by the weapons could reduce the ozone levels in the northern hemisphere by as much as 30 to 70%. Such a depletion might produce changes in the Earth's climate and would allow more ultraviolet radiation from the sun through the atmosphere to the surface of the Earth, where it could produce dangerous burns and the variety of potentially dangerous ecological effects. It's been estimated that as much as 5,000 tons of nitric oxide is produced for each megaton of nuclear explosive power. You can do the math on that. 1 megaton of nuclear explosive power equals 5,000 tons of nitric oxide. So Tsar Bomba was 58 megatons. So 58 times 5,000. That was from one bomb. One bomb. Here's the next article. Greens against nuclear power. Did nuclear weapons tests damage our ozone layer? This was from October 31st, 2015. An interesting letter appeared in the Sheffield Star back in March 2015, arguing the possibility of the ozone layer being damaged by decades of atmospheric nuclear bomb tests until they were banned by an international treaty. They sort of claim you think we'd have heard debated for years already. The science sure adds up, something New Zealand-based scientist Bill Hartley has researched in depth. Hartley blames Starfish Prime, an upper atmospheric nuclear test by the U.S. that is witnessed in 1962, is partly to blame for the ozone hole. Anyway, you can read this article, but he's saying that every time a nuclear bomb is detonated in the air, that it blasts a hole. Okay, thus when the nuclear bombs were detonated, the huge amount of light released activated the massive release of chlorine, which gobbled up a gigantic hole in the ozone. So there's that. And now we're going to look at oxygen, because our oxygen levels are falling as well. And this is from March the 10th, 2018 from sciencing.com. Minimum oxygen concentration for human breathing. This is what we have to breathe. Humans need oxygen to live, but not as much as you might think. The minimum oxygen concentration in the air required for human breathing is 19.5%. The human body takes the oxygen breathed in from the lungs and transports it to the other parts of the body via the body's red blood cells. Each cell uses and requires oxygen to thrive. Most of the time, the air in the atmosphere contains the proper amount of oxygen for safe breathing, but at times the level of oxygen can drop due to other toxic gases reacting with it. Each time you take a breath, you inhale more than oxygen. The normal air in our environment consists of a few different gases. Approximately 78% of the air is nitrogen gas, while only about 20.9% is oxygen. The remaining fraction is made up of primarily argon gas, but trace amounts of carbon dioxide, neon, and helium are also present. For humans and many animals to sustain normal functions, the percentage of oxygen required to sustain life falls within a small range. OSHA, which is the Occupational Safety and Health Administration, determined the optimal range of oxygen in the air for humans runs about 19.5 and 23.5%. Here are the side effects of not enough oxygen. Serious side effects can occur if the oxygen levels drop outside the safe zone. When oxygen concentrations drop from 19.5 to 16% and you engage in physical activity, your cells fail to receive the oxygen needed to function correctly. Mental functions become impaired and respiration intermittent at oxygen concentrations that drop from 10 to 14%. At these levels, with any amount of physical activity, the body becomes exhausted. Humans won't survive with levels at 6% or lower. Then you can have too much oxygen. Higher than normal oxygen levels aren't as harmful to life, but there is an increased change of fire or explosion risk. With extremely high concentrations of oxygen in the air, humans can experience harmful side effects. Very high levels of oxygen causing oxidizing free radicals to form. These free radicals attack the tissues and cells of the body and cause muscle twitching. The effects from short exposure can most likely be reversed, but lengthy exposure can cause death. Then altitude sickness. The right amount of oxygen starts at sea level. When altitude is increased, such as driving or climbing up a mountain, there is less atmospheric pressure. Lower pressure allows air to expand more than it does at sea level. While the ratio of the oxygen and nitrogen in the air remains the same, less molecules are available within the same space. Each breath you take at a higher altitude contains less oxygen molecules than breathing at a lower altitude. This can cause altitude sickness. Most people afflicted with altitude sickness experience nausea, headache, and fatigue. Without proper treatment, the problem can become more serious. And also, so when you're visiting, like if you live in a lower altitude area, like towards the East Coast or towards sea level, and you go vacation at a higher altitude area, you could experience altitude sickness because you're not used to the lower oxygen level that you're breathing in. And 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 for instance, also people who grow up at really high altitudes, like in South America, Bolivia, La Paz is at 14,000 feet altitude, and none of us here in the United States are used to that. So if you're going to go live there, I mean, you could experience huge problems. But people who are born at that altitude, their lungs adapt, and their lungs grow very big and adapt to the lower amount of oxygen. So it might be okay for you to visit for a little while, but to actually move there to that higher level would be difficult for your body to adapt. Atmospheric oxygen levels are dropping faster than atmospheric carbon levels are rising. And this was posted by Good German, January 27th, 2013. Forget rising temperatures and bigger storms. This is the big problem that neither side of the mainstream debate over environmental destruction is talking about. Peter Tatchell reported for The Guardian back in 2008. The rise in carbon dioxide emissions is big news. It is prompting action to reverse global warming, but little or no attention is being paid to the long-term fall in oxygen concentrations and its knock-on effects. Compared to prehistoric times, the level of oxygen in the Earth's atmosphere has declined by over a third, and in polluted cities the decline may be more than 50%. This change in the makeup of the air we breathe has potentially serious implications for our health. Indeed, it could ultimately threaten the survival of human life on Earth, according to Roddy Newman, who's drafting a new book, The Oxygen Crisis. I'm not a scientist, but this seems a reasonable concern. It is a possibility that we should examine and assess. So what's the evidence? Around 10,000 years ago, the planet's forest cover was at least twice what it is today, which means that forests are now emitting only half the amount of oxygen. Desertification and deforestation are rapidly accelerating this long-term loss of oxygen source. The story at sea is much the same. NASA reports that in the North Pacific Ocean, oxygen-producing phytoplankton concentrations are 30% lower today compared to the 1980s. This is a huge drop in just 3 decades. Moreover, the UN Environment Program confirmed in 2004 that there were nearly 150 dead zones in the world's oceans where discharged sewage and industrial waste, farm fertilizer runoff, and other pollutants have reduced oxygen levels to such an extent that most or all sea creatures can no longer live there. Now this was 2004, 150 dead zones. And that was 14 years ago. So we have a lot more dead zones in the ocean now. This oxygen starvation is reducing regional fish stocks and diminishing the food supplies of populations that are dependent on fishing. It also causes genetic mutations and hormonal changes that can affect the reproductive capacity of sea life, which could further diminish global fish supplies. This could also explain the thousands and thousands of dead fish just washing up on the oceans, on the seashores everywhere, and along with Fukushima and all the other stuff. Professor Robert Berner of Yale University has researched oxygen levels in prehistoric times by chemically analyzing air bubbles trapped in fossilized tree amber. He suggests that humans breathed a much more oxygen-rich air 10,000 years ago. Further back, the oxygen levels were even greater. Robert Sloan has listed the percentage of oxygen in samples of dinosaur-era amber as 28%. That was 130 million years ago. 29% 115 million years ago. 35% 95 million years ago. 33% 88 million years ago. 35% 75 million years ago. 35% 70 million years ago. 35% 68 million years ago. 31% 65.2 million years ago, and 29% 65 million years ago. And so on. I'm going to jump to the end. Well, this is also interesting. I hate to leave it out. I'm just going to go on. Professor Ian Plimer of Adelaide University and Professor John Harrison of the University of Arizona concur. Likely most other scientists, they accept that oxygen levels in the atmosphere in prehistoric times averaged around 30 to 35% compared to only 21% today, and that the levels are even less in densely populated, polluted city centers and industrial complexes perhaps only 15% or lower. Much of this recent accelerated change is down to human activity, notably the Industrial Revolution and the burning of fossil fuels. The professor of geological sciences at Notre Dame University in Indiana, J. Keith Rigby, was quoted in 1993 and 94 saying, "In the 20th century, humanity has pumped increasing amounts of carbon dioxide into the atmosphere by burning the carbon stored in coal, petroleum, and natural gas. In the process, we've also been consuming oxygen and destroying plant life, cutting down forests at an alarming rate, and thereby short-circuiting the cycle's natural rebound. We're artificially slowing down the one process and speeding up another, forcing a change in the atmosphere. Very interesting, but does this decline in oxygen matter? Are there any practical consequences that we ought to be concerned about? What is the effect of lower oxygen levels on the body? Does it disrupt and impair our immune systems and therefore make us more prone to cancer and degenerative diseases? The effects of long-term oxygen deprivation on the brain, called cerebral hypoxia, are known, and some sound reminiscent of the general rise of stupidity in the industrialized world. Professor Irvin Laszlo writes, "Evidence from prehistoric times indicates that the oxygen content of pristine nature was above 21% of total volume that it is today. It has decreased in recent times due mainly to the burning of coal in the middle of the last century. Currently, the oxygen content of the Earth's atmosphere dips to 19% over impacted areas and is down to 12 to 17% over the major cities. All at these levels, it is difficult for people to get sufficient oxygen to maintain bodily health. It takes a proper intake of oxygen to keep body cells and organs and the entire immune system functioning at full efficiency. At the levels we've reached today, cancers and other degenerative diseases are likely to develop, and at 6 to 7%, life can no longer be sustained. More specific details regarding the drop in atmospheric oxygen can be found here. And that's the end of that article. Then there are lots of comments. One more article, and then we're going to wrap it up for today. From Science and Society archive. Not sure when this was done. O2 dropping faster than CO2 rising. Implication for climate change policies. This is talks more about what we just read, but it's another article measuring O2. And it's interesting that CAMS doesn't measure oxygen. I don't know why they don't. They measure everything else. You know, maybe they don't want us to see how bad everything is getting. And then there's an oxygen sink, climate policies, etc., etc. So the way I see it is we're suffocating, oxygen levels are going down day by day. The ozone layer is being depleted. The bad ozone is increasing around the world. Carbon dioxide is increasing. Everything is... The house of cards is falling, folks. And it's falling fast. And so I think we are in the end times. We don't have much longer. And it is time to get your spiritual house in order. I do believe that the earth has been hijacked and taken over by a dark satanic force from a very long time ago, and worked on the minds of the individuals who were in charge so that they would make the choices, the worst choice possible at every turn, at every juncture point. We had a choice. You look back, Nikola Tesla, at his remarkable inventions and discoveries, and the world would have been so much different if his research and discoveries were used for good instead of evil. We would have had free energy. You know, he was utilizing the energy of the earth, and everybody would have, he wanted free energy for everybody around the planet, but they couldn't let that happen. And instead, look at where we're at now. And then after he died, and you know, I don't know if he was killed or not, he probably was, that they went in and raided his laboratory and took all of his notes and all of his research, and now we're using his research for Tesla cars and also for space weapons and, you know, mass destruction and things like that. It's just like, it's too much. So I am Christian. I do believe in Jesus. I do believe that He came as our brother to show us how to live and to show us how to ascend. He did master ascension. He mastered the human condition, but He suffered. And if you haven't gotten right with God and Jesus, now would be a good time. Until next time, my name is Margo. I'm a hypnotist, holistic life coach, empathic spiritual healer. My website is margoshealingcorner.com. Until next time, go in peace, God bless, and good